from Persona, but this is not a testing session anymore, and we will start at 3:10 for the real session.
Okay, thank you.
Hello, good evening, everyone. Thank you so much for your participation on virtual seminar Impulse ITB 2021, Multifaceted Perspective of Smart City Concept in Indonesia New Capital City. Let me introduce myself first. First, my name is Gina Shalendra, and you can just call me Gina, and I'll be your moderator for today's session. And as a moderator today, I will try to lead the discussion, and you happen to have a question or you want to communicate with the speakers, you will have to connect with me first. And I will also represent the committee to express our biggest thanks to all the sponsors of this event, PT Pegadaian, Persona, and Telkom Infra. Before we start, I will inform you about some rules that I hope you guys will have to comply. The first one, if you need to say something, you may use the chat room accordingly. And the second one, if there are any questions, you can directly ask through the Q&A panel on the bottom right, and the speaker will answer it through the Q&A session, and make sure that you have to ask in polite manner. I think that's all for the rules. And in addition, here are the good news for you. There will be 3 questions in the form of quiz in the Q&A session. It is a 1-minute quiz, and you will have to answer it. And the fastest with the highest score will have a total prize of 150,000 rupiah GoPay. Okay, so on our third session, we are going to talk about the implementation of smart city technology in Indonesia, as well the role of AI power hiring process in a government, in a smart governance. And now we already have 2 speakers that will enlighten us this evening. The first one is Mr. Gerald Kwas. Hello, Mr. Gerald.
Hello. Hey, how are you, Budina?
Yeah, I'm fine, Mr. Gerald. Mr. Gerald here is the head of business units of Digital Grid Siemens Indonesia. And our second speaker is Mr. Ahmad Nur Sukma. Hello, Mr. Sukma.
Halo, Mbak.
Hello, Mr. Sukma. Mr. Sukma here is the CEO of Persona, and he will explain about the role of AI power hiring process in smart governance.
Yes.
Okay, I think so we are ready to start. So I think I will welcome our first speakers, Mr. Gerald Kwas. Without further ado, Mr. Gerald, the time is yours.
Thank you very much, Budina. Thank you very much, Jonathan, and thank you, ITB, for having the opportunity to participate in today's afternoon's webinar. This is number 1. Number 2, I have to apologize because our CEO and President Director, Mr. Prakash, is unfortunately not able to join this afternoon. There has been some conflict in his schedule, but anyway, he's sending his best regards to all of you, and also would like to participate in one of the upcoming sessions then again with ITB. So I will take it from here. As mentioned already, my name is Gerald Kwas. I'm heading the Digital Grid Business Unit here in PT Siemens Indonesia. And I would touch on 2 topics actually. First thing is a brief overview about Siemens in Indonesia. And the second one about smart grids, and specifically here the roles of microgrids and renewable distributed energy sources. So let's just kick it off with the overview about Siemens in Indonesia. Actually, under the roof of PT Siemens Indonesia, we are running 3 businesses. Number 1 is called Smart Infrastructure. It's consisting of 4 business units. One is distribution systems, taking care about medium voltage switchgear. Number 2 is Digital Grid. This is actually the business unit I'm heading, and we are taking care about all automation, protection, and digitalization portfolio when it comes to energy automation. So smart grid actually is touching the core of our business, right? We do have also business units taking care about electrical products and building products in smart infrastructure. The second one is digital industry, actually mainly taking care about factory automation and the digitalization and automation of processes. This is number 2. And number 3, Siemens Energy. It's all about, as the name said already, about energy generation, energy transmission, and related services, be it conventional or also digital. As per last year, which was heavily impacted by COVID-19, as you are all aware of, we generated a revenue of roughly 250 million euros, and we do employ around 1,000 people within Siemens Indonesia. Looking at the production sites we have across the country, the main factory is located in Pulau Mas in Jakarta. This is also where the business units in smart infrastructure are located. And here we have a factory manufacturing mainly medium voltage and low voltage switchgear, but also protection and automation panels for the substation automation area. We also have a plant in Cilegon, taking care or acting as a repair center for rotating equipment coming from the generation side of things. and also in Batam, a factory, I will call it, where we are producing e-houses, so containerized solutions for the energy supply in the global oil and gas market, right? Additionally to that, we do have a number of local collaborations or corporations going on. Number one is Travo Indo Power Indonesia. So this is actually a joint venture company for the production of power transformers. It's also located in Jakarta, actually. Number two, and also this one already touching some sort of the smart grid area, is about IoT connectivity with Sewatama to enable actually digital services by applying IoT and cloud-based applications. Number three, Twink Indonesia, also here a partner agreement, technical collaboration for the production of high voltage products, I would say, so mainly circuit breakers, but also gas insulated switchgear. Last but not least, or actually not last, but also mentioned here, Indonesia Power, where we have a memorandum of understanding (MOU) in place for the realization of, or for the utilization of virtual reality technologies for the power plant optimization. One thing I would like to mention here as well, but it's unfortunately not shown on this slide, is we do also have collaborations with ITB already in place, where we a couple of years back supplied software licenses actually, and also lab equipment for a laboratory in ITB in the area of grid simulation and grid planning software. And also for substation automation and protection. Just last year, we introduced a demo system actually for ITB, taking care about substation automation and protection. So this is just as a rough overview about the company, Siemens in Indonesia. As you can see, we are here since more than 160 years already, and pretty much looking forward to the next 160 years. So now coming to the topic, talking about smart grids within, let's say, 15 minutes is quite a challenge, as you can imagine. So smart grid is literally touching each and every aspect of our energy systems, right? It is not only touching our energy system, it's also touching societies. The way we are producing, the way we are consuming energy, the way we are working, and the way we are living. So all these aspects are touched by the topic of smart grid, and that's why I would like to focus on one specific topic, microgrids, as an essential part of microgrids actually, and the role of distributed renewable, ideally renewable energy resources in a smart grid, right? So looking at what drives us as a vendor, or what is driving utilities towards a smart grid, there's many different drivers if you look in the details. But at the end and at the highest level, I would say it is all about climate change. The climate change we are facing globally and locally, of course, as well. And coming along with that, the need for distributed and renewable energy resources. Right, and together with the potential which we see in digitalization and the progress we made in developing digital technologies during the past, so all these are considered as a key driver for smart grids, right? We are all aware of the, let's say, typical layout of energy systems in the past, and to some extent also today. So where we do have big centralized power generation, be it fossil, be it nuclear, be it hydro, or also in Indonesia specifically, be it geothermal generation. So all these is generated centrally in big power plants and then transmitted via transmission lines and distributed towards the consumers in a, I would say, unidirectional way. So this is the layout of the past and the layout of the energy systems we are seeing to some extent also still today, but this will change. This will change significantly. And if you the system, if you look at this picture, and you will see that the system becomes way more complex. And this is mainly due to the increasing infeed of distributed and renewable energy resources, be it on, let's say, utility scale or large scale level in a sense of onshore or offshore generation, be it in a sense of utility scale, large scale PV power plants. So all these are significantly changing the layout and the design of the energy systems. And talking about the onshore, offshore generation, talking about big PV power plants, we are talking about a range in generation capacities per site of gigawatts in the meantime. So the transmission system actually will remain an important part of a smart grid. And by utilizing new technologies, digital substation, utilizing process bus, for example, non-conventional instrument transformers, for example, applying wide area monitoring and protection systems, all this will help to move the energy systems or the energy transmission system in that regard towards a more smarter or towards a smarter system in the future, actually. But the majority of change is actually happening in the distribution grid, right? And here you see in the upper right corner, actually, there's lots of new players coming into the picture. We do have lots of distributed resources, energy resources coming into the picture, be it wind power, be it solar, be it hydro. But we also see that there's increasing demand of e-charging infrastructure, also specifically in Indonesia. We see a development towards having e-vehicles in our streets, actually. We have buildings suddenly not only consuming energy anymore, but also acting as a producer of energy, for example, or acting as a storage for energy. So all this actually needs to be managed, needs to be integrated in a proper way. And this is exactly where the so-called microgrid controller comes into the picture, right? And to just give you a glimpse of the impact of what renewable energy is doing to the energy systems worldwide, I have an example from Germany, actually. We call it energy or Energiewende, energy transition. So the ambitious target for 2030 actually is to have a share of renewables of about 65% already. Today in 2020, we are sitting on a level of, let's say, 45%, and the majority coming from offshore wind generation, where we have large wind power plants in the northern part of the country, actually. But this is also then challenging the transmission system quite a bit, because this energy has to be transmitted towards the south of the country, because there are the load centers, actually. There are the big industries consuming the energy, actually. And this can be supported to some extent with smart grid technology, but at the end, it is also about putting new transmission lines in place, putting new HVDC links, for example, into place in order to transmit the energy from the north to the south of the country. But now looking forward and looking to the ambitious target, as I mentioned before, to reach the 65% of renewable energies in our energy mix in Germany, then it is all about small, hundreds of thousands, small distributed energy resources, be it rooftop PV, for example, or be it small and mid-sized PV generation, which is typically then infeeding on a distribution level into the energy system, right? So I think we all would agree that the key drivers for societies are actually decentralization, decarbonization in all aspects of our life, and digitalization. Specifically, digitalization, again, as we made a tremendous progress in technology during the last decades, actually. So all this needs to be supported by a resilient, efficient, and sustainable energy system, right? Specifically, sustainability is a key aspect. making sure that we are utilizing more and more renewable and more green energy sources in our energy mix of the future. Okay. So, but how to make all this happen, right? How to manage the changed energy supply side of things, so to speak. How to manage the changing environment in the energy demanding or in the energy demand landscape, where we do have not only consumers anymore of energy, but also production of energy, the prosumers, as I mentioned before, or in other words, how to manage what we also call the grid edge, where everything comes together actually. And this is where microgrid solutions are actually filling this gap by integrating all these different types of assets I mentioned before, in a sense of energy storages, for example. So battery storage is getting more and more attractive, integrating all sorts of small and medium-sized distributed energy systems, but also, for example, looking forward also in Indonesia specifically, enabling e-mobility, actually a charging infrastructure for e-cars is also a key aspect of the microgrid solutions actually. Digitalization coming along in all areas actually, and enabling lots of interesting and powerful new business cases. In the sense of smart buildings, I just mentioned this, having buildings acting as a producer of energy, having buildings acting as a storage of energy, e-charging I mentioned already, and also smart metering, to just touch a few of the items actually. So this is all about the microgrid and the microgrid controller. And as I mentioned before, there's lots of different assets and lots of different aspects we have to consider. So first of all, it is about the local generation, which will be integrated into microgrids. Could be still fossil to some extent. So diesel gensets, for example, could be a player in that area. It could be biomass. It is about wind. It is about medium up to large scale PV. It is about batteries. So storing energy is a key aspect of the microgrids, so to speak, as well as small energy resources in the sense of rooftop PV, for example, which also needs to be integrated. E-charging, I mentioned already, and all sorts of other controllable loads from an industry or from a community perspective. A microgrid typically can be run in a grid connection mode. So this is a typical configuration actually, where you still have a connection to the utility, but obviously one of the use cases is also to have microgrids running in a grid off or in a not connected mode, so to speak, specifically looking at remote islands, for example, or remote locations where there might be no grid access, for example. So microgrids could play a key role in that area as well. Looking at the use cases, there's many. I just want to focus on 4 of them a little bit more in detail. And the first one obviously is all about transparency. So having the communication facilities available, having online connectivity to all your assets in your microgrid, this is providing you a lot of benefit already in terms of predictive maintenance, for example. Optimized value streams, or in simple words, just the balancing of generation and loads in a microgrid, which is done by the microgrid controller as well. And then also very, very important, the optimized energy mix, talking about renewable energy sources, talking about optimizing the mix of your energy supply in a proper way is also one of the portions actually of a microgrid controller. And the last one, last but not least, I cannot see it in here, but it is about the off-grid usage of microgrids, for example, for remote islands, for remote locations, to make sure that independent power grids can be also established in that kind of areas, right? Now, looking a little bit into the details of those business cases, And I hope you can see this fancy animations in here. Looking at transparency, just a simple example. Just imagine you have some PV installed and this PV panel, for whatever reason, is getting soiled. So if you have a standard reporting, getting the reports of the production of the PV panels only once per month